Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of real-world quadratic functions. This is standard A.8B in the great state of Texas, and we are using item number 39 off the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a set of xy coordinates here, and height and time, and we're looking to find an equation, a quadratic equation that best fits this model. We don't know much. We know that the time generally just increases here, right? So if I were to make this my t, and this is my height, right? So this is going to be my h of t here. It's just gonna, the time is just gonna move forward from 5 to 35 here. But look what happens to my height, right? So it starts kind of high. Looks like it peaks right there at about 30 seconds. So if I were to say my 30 seconds, we're gonna be like this. Kind of peaks. And then it comes back down. That's about all the data we have, but we can assume that the parabola is gonna come back down this way as well. Now we're supposed to turn that into an equation. How do we do that? Well, as you can see on the screen, we have a TI-84 calculator, because this is one we don't do without any type of technology, at least not in Algebra 1. Maybe later on in higher math you will, because we're really looking to use a process called quadratic regression. And quadratic regression is helping us find a parabola of best fit. So we're going to take this data right here. We're going to use the scientific calculator, or the graphing calculator actually, and we are going to find something that's close to one of these standard form statements. So we need to recognize that we're looking for standard form, because what we're going to get is we're going to get an A, we're going to get a B, and we're going to get a C. So this quadratic regression, like I said, is looking for a parabola of best fit. Alright, so how do we do that? Well, there's multiple ways to do it. I'm going to show you how to do it on the TI-84. So we're going to go to this stat line right here. So if we go to this third row on the top, we're going to hit that stat. And then we want to hit enter. We want to edit. We're adding our two lists here. So list 1 is going to be the time. And list 2 is going to be the height. Biggest problem here is just entering in something correctly. So we need to just make sure we're hitting all of these correctly, because if we do it incorrectly, obviously we'll get different results. So list 1 is going to be fine. It's going to be that list 2, 1, 3, 5, 3. We're not worried about commas here. We're just going to enter in the raw numbers, 3, 3, 2, 3. 3940, 4313, 4440, and then 4323. Alright, so if you need to, right, go ahead and double check. Make sure everything looks fine. Now we're going to go back to the stat, and you see there's a menu on the top, Edit, Calc, and Test. So we actually have to hit this right button to pick up Calc. Now we're going to calculate, now that we have our two lists, because there's obviously a lot of things we can do with those two lists, we're going to hit number 5 there, quadratic regression. We've already got our list. Our x's are list 1, our y's are list 2, which we've already entered. Now we're going to go down here to calculate. That's all it's going to give us. You might be wondering, well, what in the world does that mean? Well, remember, we're looking for it in standard form. So our A is going to be negative 4.899, let's call that 4.9. Our B is going to equal 294.96. And then our C is going to equal 0.57. All right, and we need to find which one looks at that best. Well, obviously this A is 0.49. That's going to cancel A and D. 2.94.96, that works both there. 0.57 works best with that B, so that is our answer.